Okay, viewers, myself is Dr. K.S. Kumar, Associate Professor of Chemistry, C. Siddhartha, First Grade College. I would like to interact you about the bioenergetics, that is, as well as the electron transport chain. Before I go into the bioenergetics, let me clear something regarding the that is free energy concept. The concept of free energy. In thermodynamics, it is very clear. Free energy is the measure of the amount of usable energy in the system. So, free energy is the one which can be converted into work. Free energy is the only form of energy which can be converted into work in the isothermal system. And free energy is a state function, and the exact value of this free energy cannot be determined for any system, but if it changes from one state to another state, so this can be determined. That means you can determine only the change in free energy. Change in free energy can be determined. So that is, as I said, delta G is equal to G final minus G initial. So that is what I mentioned. So free energy is the only form of energy which can be converted into work. And of course, this free energy is actually related to the other thermodynamic data, to the enthalpy as well as the entropy. And the free energy, the value of free energy change also depends upon the temperature scale. Then, how this free energy is related to the other thermodynamic data, that is enthalpy and the entropy. See, free energy is change in the system is very useful to know about whether the process is spontaneous or not, whether the process is feasible or not. And this free energy is the only form and ultimate form which is going to decide the spontaneity of the process. And this free energy is related to the other thermodynamic parameters, that is delta H and delta S. So delta H is the change in enthalpy and delta S is the change in entropy. And these two factors contribute a lot to the change in free energy value. And of course, the absolute temperature also makes a difference. Why we have to give much importance to this delta G? Because so it is going to decide the spontaneity of the process. So that is, and if the free energy change is a negative quantity, the spontaneity is there. If the delta G is positive quantity, there is non-spontaneous process. Okay. Then we shall understand what are exergonic reaction and what are endergonic reaction. These terms are very much similar to the endothermic, exothermic reactions, but exactly they refers to the free energy. So exergonic reactions are those in which the delta G is negative. Endergonic reactions are those in which the delta G is positive. In exergonic reaction, the free energy of the reactant is greater than the free energy of the product. So if the delta G is negative, the process is spontaneous in nature. So all exergonic reactions are called spontaneous reactions. Okay, they take place themselves. All endergonic reactions are non-spontaneous in nature. So the free energy change is a positive quantity or greater than zero. Therefore, they are the non-spontaneous in nature. Next. And let us see some of the examples of the exergonic reactions and the endergonic reaction. First, you know the definition. An exergonic reaction refers to a reaction where energy is released. Exergonic reactions are those in which the delta G is negative. And in these reactions, the free energy of the reactant is greater than the free energy of the product. Therefore, the delta G is negative. Such reactions takes place themselves and they are the exergonic reaction. One such example is the combustion of glucose. Combustion of glucose to carbon dioxide and water is an exergonic reaction. It is going to release the energy. That too, it takes place at the cellular level. An endergonic reaction is quite opposite to the exergonic reaction. where the energy is absorbed. The delta G is positive for this endergonic reaction. One of the basic example for this endergonic reaction is the photosynthesis by the plants. It requires energy and it takes place at the consumption of the energy. It absorbs the energy, what I mean. Next. Now let us see what is meant by the energy coupling. A chemical reaction having a common intermediate in which the energy is transferred from one side of the reaction to the other side. In other words, you can say the energy released in exergonic reaction is utilized to run the endergonic reaction. I also say that, so this is the energy of the exergonic reaction is the driving force for the endergonic reaction. A biologically unfavorable endergonic reactions are actually carried with the help of the biologically favorable reaction. The mechanism of utilization of the energy released in exergonic reaction to run the endergonic reaction is called energy coupling. That too it takes place in the cellular level. Let us see one of the example for this energy coupling. You can observe this first reaction, that is the hydrolysis of the ATP and the transfer of hydrolysis of the ATP, this first reaction to ADP and the glucose 1-phosphate. So that means glucose is converted to glucose 1-phosphate. ATP is converted into ADP. This is a transformation of the phosphate group from ATP to the glucose molecule. This typical reaction is an endergonic reaction, energy requiring reaction. It requires 27 kilojoules per mole to complete. You can observe another reaction, that is glucose 1-phosphate transfer that phosphate group to the fructose and phosphate group, and this glucose and fructose join together to construct the sucrose. That is the construction of the sucrose unit and releasing the phosphate. So this reaction is an exergonic reaction. So it releases 30 kilojoules per mole. And these two reactions you can observe. The first one is an endergonic reaction, biologically unfavorable reaction. And the second one is the biologically favorable reaction. The energy released in this biologically favorable second reaction is utilized to run this biologically unfavorable reaction. This mechanism is called energy coupling in the chemical reaction. And the combination of these two reactions is nothing but the combination of the glucose and fructose with the help of the ATP to generate the sucrose, and that ATP and hydrolysis is converted into ADP and inorganic phosphate. The combination of these two reactions is typical exergonic reaction. In this way, so energy of one reaction is utilized to run the other reaction. This mechanism is called energy coupling. We have so many examples of this category. This is one such example of energy coupling. Next, for the next one, that is the least one here mentioned, is the minus values. So why I mentioned this, why I am introducing these things is, these are the many of them serve as the carriers in the electron transport system, and their redox potential values is also arranged, and that is standard redox potential value. So standard redox potential is the measure of ease with which a molecule accepts electron value. So positive, the more the positive the redox potential value, the more readily the molecule is reduced. That means it itself reduces and it serves as a good oxidizing agent. In other words, you can say, so the molecule serves as a good oxidizing agent with highest potential value, and the molecule with lowest redox potential value serves as a very good reducing agent. And this molecule is going to reduce to the maximum extent, whereas this molecule is going to oxidize to the maximum extent. So these are the redox potential values of certain biologically important materials. Next, a very important thing in this chapter, that is the electron transport chain. I have given a brief definition for this electron transport chain, or you can say a concise definition. There is a stepwise transfer of electron from reduced substrate to the molecular oxygen through number of intermediates called electron carriers whose redox potential gradually increases and finally reaches the molecular oxygen is called electron transport chain. I include all the things in one sentence, that is stepwise transfer of electron from reduced substrate to molecular oxygen through number of intermediates called electron carriers whose redox potential value gradually increases and finally reaches the molecular oxygen is called electron transport chain. And this is what is our respiration. This is what is the oxidation that takes place in the cellular level. So you can see the chain of reactions that takes place here. So you can see here from NADH, which is the reduced substrate. So in biological term, though the electrons are finally transferred from reduced substrate to the molecular oxygen through number of electron carriers, so whose redox potential value according to the table gradually increases and finally reaches the value of the molecular oxygen. So electrons are transferred from this NADH to the molecular oxygen through number of carriers, and these carriers have got the redox potential value gradually increases and finally reaches the molecular oxygen. You can observe, you can practice this chain of reaction. The electrons from NADH are transferred to the FMN, and the FMN becomes FMNH2, and from this FMNH2 the electrons are transferred to the coenzyme Q. That coenzyme Q becomes CoQH2, that is from CoQH2 it is transferred to the cytochrome. We have the set of 4 cytochromes in this electron transport chain: cytochrome B, cytochrome C1, cytochrome C, and cytochrome B and cytochrome C1, cytochrome C and cytochrome C plus A. Is it? Okay, that's another cytochrome. So the electrons are transferred in this manner and finally to the molecular oxygen. You have to learn this schematic representation of this electron transfer. So I repeat, the electrons are transferred to this molecular oxygen. At these during the transfer of electron, so the various stages, measurable amount of energy is released, and that energy is utilized to synthesize the ATP molecule. You can see when the electrons are transferred from NADH to the molecular oxygen, at 3 stages the ATPs are synthesized. Suppose if the electrons are transferred from the succinate after transferring becomes fumarate, and this from this it is transferred to the FAD becomes FADH2. So from FADH2, so it is the electrons are transferred to the CoQH2 and it repeats. So you will have the synthesis of the 2 ATPs if the electrons are transferred from the succinate, and 3 ATPs when the electrons are transferred from the NADH. I repeat, it's an important question, the electron transfer system or electron transport system, and this is what the typical representation of the respiration. This is the one where the oxygen is used as the oxidizing agent. Oxygen is used as the ultimate oxidizing agent. That is the reason why we need oxygen for the respiration, why we need oxygen for the oxidation, why the cell needs this oxygen molecule for its energy production. Next thing is, and I am going to read the definition of the oxidative phosphorylation and the substrate level phosphorylation. What is oxidative phosphorylation? I told you while telling about the electron transport chain, electrons are transferred from this reduced substrate to the molecular oxygen ultimately. This is another schematic representation of the electron transport chain. You can observe here in this yellow mark, that is ATP is synthesized when the electrons are transferred from FMN to the cytochrome at this stage. So the FMN transfers the electron to the cytochrome, ATP synthesized here, ATP is synthesized again, and ATP is synthesized here. The production of the ATP molecule along the electron transport chain is called oxidative phosphorylation. I told while explaining the electron transport chain, energy is released at various stages, and that energy is utilized to synthesize the ATP molecule. So oxidative phosphorylation means nothing but the production of the ATP, the synthesis of the ATP by consuming the energy released during the transfer of electron from reduced substrate to the molecular oxygen. The next thing is the ATPs are not only synthesized during the electron transport chain but also synthesized by the direct phosphorylation. So that is the substrate level phosphorylation. The production of the ATP molecule by the direct transfer of phosphate group to the substrate is called the substrate level phosphorylation. So the phosphate group is synthesized, the transfer from this 1,3-diphosphoglycerate to the ADP molecule. That ADP becomes ATP and this one becomes the 3-phosphoglycerate. This is a typical reaction of the glycolysis. You can observe here ATPs are synthesized not by the electron transport chain but by the direct phosphorylation. If the ATPs are synthesized by the direct phosphorylation from one substrate to the ATP, so that's called substrate level phosphorylation. This is a repetition reaction that is it can be observed in the glycolysis chapter. Then with this I am going to conclude this chapter. So that is the bioenergetics and the electron transport chain. And I want to stress upon the important questions that are possible in this chapter. Importantly, you should understand what is the exergonic reaction and endogonic reaction. And we should learn what are the examples for the exergonic reactions and the endogonic reactions. The question will be like this: what are exergonic and endogonic reactions? Give example. The second question is, so what is the energy coupling? So give the mechanism of coupling of the energy coupling reactions. The next question is, what are high energy compound or energy rich compounds? So give example. The next is give the structure of the ATP and explain the features that makes it as a high energy compound. You have to learn the structure of the ATP and you should explain why this ATP is a high energy compound. The next is about the electron transport chain. So you have to give the schematic representation of the electron transport chain and you should explain what is an electron transport chain. So you may be asked to write what is an electron transport chain or electron transport system. Give the schematic representation of this electron transport chain. The next question is what is oxidative phosphorylation? Give example. What is substrate level phosphorylation? Give example. Okay. So these are the important questions in this chapter. Thank you. If you like this video, so you subscribe to our channel and leave likes. Thank you very much.